Okay, hello guys. For this video, I want to find the average value of this function on that interval. So first, let me actually solve the problem, and then I'm going to show you why you should believe that formula. So first, like the formula is the following: that you're going to take a fraction of 1 over the difference of your boundary points a and b, and times the integral of your function of a and b of f(x) dx. So in our case, what do we have? We have just 1 over 7 minus 0 times the integral from 0 to 7. And you can see how I'm doing computation here. But basically the idea of that average value, that you take the value of your function over a finite interval, which is the area, and divide by the length of the line segment. Or in other words, you're looking for how much area do you have on average on a certain interval. And you can see that if you're going to compute that integral, then my final answer is going to be just 49 over 3 minus 3 times 3 over 3, or in other words of 40 over 3, which is approximately 13.3. So let's now explain again like this formula, and let me give you some examples. So let's take two numbers, and those two numbers can represent the areas of two rectangles. So the average of those two numbers is going to be just a plus b over 2, where I'm going to say just I have a first and second rectangular. Then we can do the same with three numbers, or like three rectangulars. So I'm going to have a, b, and c. And then you can see that the average of three numbers is going to be just a plus b plus c over 3. And we can just generalize that concept or this idea if you're going to have like n numbers or n rectangular. So I'm going to name them a1 up to an, and then the average is going to be a1 plus a2 plus dot 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 plus an over n. But then like how do we apply this to our like integral? So let's take some function on a closed interval between a and b. And then the idea is that what can I do? I can, using the definition of integration, I can divide my domain into equal line segments. And for each of the line segment, I'm going to take some function value. So what I'm going to obtain this kind of rectangular. Or in other words, if I'm going to divide my domain by n equal rectangulars, I'm going to just find the approximate average value of my function on that closed interval. And the way how this formula is derived, I believe you can look at the book, but basically the idea is that we are building the Riemann sums, and if we're going to take the amount of our like segments and send them to infinity, but again, like we're going to divide our interval with smaller and smaller segments, and then we're going to obtain the actual interval. Or in other words, you can imagine that at the limit, our like interval is going to be filled in with those vertical lines, where each vertical line is going to be the value of my function over that interval, and then 1 over b minus a is going to be the amount, how many like those lines do we have, and then each green point is going to be just the value of my function. So we can see the analogy between like finite finding the average of numbers when again going to take the finitely many numbers, or if you're going to find the average numbers, or if you're going to find the average value of a function when the function is given on some closed interval. Okay, so let's do one of the homework problems where I want to compute the average value of this function x ln of x on a closed interval between 1 and e. So let's actually compute this integral. So I'm going to have 1 over e minus 1, the integral between 1 and e, x ln x dx. And again, like I'm going to use integration by parts to compute that integral. So for that, I need to make a choice. What is my u and what is my dv? And we have two options. Either I can say like dv is ln x or x. And if I'm going to choose ln x, then how do I find the integral of ln x? That's difficult. So that's why I'm going to choose that dv is going to be my x. And then you can observe that if u is equal to ln of x, then du is pretty simple, 1 over x. So when we're going to apply integration by parts, I'm going to obtain x squared over 2 times ln of x between 1 and e minus the integral of 1 over x times x squared over 2. And x squared is going to cancel, so I'm going to end up with just x over 2. And of course, don't forget about the factor in front of my integral. So if I'm going to plug in my boundary points, I'm going to obtain e squared over 2 times ln of e minus 1 squared over 2 times ln of 1 minus my integral, and I'm going to do that algebra simplification. And then I need to remember a couple of properties of logarithm. So ln of 1 is always 0, and ln of e is just log base e of e, but log base of the same number is going to be just equal to 1. So I'm going to obtain 1 over e minus 1, e squared over 2 minus 1/2, where 1/2 is just a constant which I factor in front of my integral. And integral of x is just x squared over 2 between 1 and e. And after I'm going to do like some simple algebra, you can see that I'm going to obtain the final answer, which is equal to 1 over e minus 1 times e squared plus 1 over 4.